There's one more way to refer to libraries, and that is dynamically at runtime. So instead of having the linker, instead of when you're linking the program to supply it, not have any direct references and use this reflective API, dlopen and dlsim, to get values, to get variables, functions, other pointers out of a library. So dlopen takes the name of a file. That should be a shared object file, so like libc.so. It also takes some flags that say how to open it. And then dlsim takes a handle returned by dlopen, so it takes a handle to one of those shared objects, one of those shared libraries, and then it takes a string for a symbol, and it goes and finds the address of a function or variable in the shared object. It loads the shared object into memory so that it's part of the running program, and then gives you a pointer to the corresponding variable or function as defined by the shared library. Let's look at another example. Here I have a program that is using the cosine function as declared in math.h, and I'm applying it to a floating point decoding of the argument provided on the command line. So if we try to compile main.c, we get an error saying it doesn't know what cosine is. Even though cosine is standard, it's not in the C library. On Linux, it's in the math library, which is abbreviated just M. So if we link to the math library, then we'll have it. And if we look at LDD output, then we see that, yes, the math library is linked in now, and we can run it. Oh, I'm supposed to give it an argument. I didn't include any checking at all. Okay, so cosine of about pi is about -1. So that was just illustrating -L to link in the math library. But now what I'm going to do is not have a direct reference to cosine. Instead, I'm going to get the cosine from dlsim of the libmath library, which I will have to define m in a minute, libm in a minute. I'm going to get the cosine function out. So cos pointer is, well, it's a function pointer, and it's a function that takes a double and returns a double. Okay. So I can put that at the top, or I can put it in here. I could even declare that variable and then initialize it like that. So this may be a little hard to read, and it's not usually written that way, but just for demonstrating it, what I'm declaring here is cos pointer. That's my local variable, but its type is that it's a pointer to a function where the function takes a double and returns a double. But I still have to deal with libm here. So libm, that I get with dlopen. Sorry, I misspelled dlsim. dlopen, saying that I want the math library. And then I need to say that it should try to figure out the bindings right away. That's what rtld, runtime load now, means. As you load the library right away, make sure that all of the variables that it's expecting, all the functions that it's expecting, are available. So with this change, now I can compile main again. Okay, we got some problems. It doesn't know about RTLD now. That's because I need to include dlfcn. So that's the header that declares dlopen in dlsim. Okay, try to link. That doesn't work still, because dlopen and dlsim are not standards. They're in the DL library. So now that I've linked those together, I can run, and I can call 3.14. But if we look at a.out, it is no longer statically linked to libm. Libm is not automatically used when I start running this program, although libdl is now. But libm gets loaded in when dlopen executes. And, dlopen searches for shared objects in essentially the same places that GCC does, or the linker does. And so it finds that shared object, and then from that shared object I get the address of the function cosine, which I assign to a function pointer, and then I have an indirect function call here. If we were to disassemble this, I haven't tried that, but let's try that out. So let's compile it with optimization so it looks reasonable when we disassemble it. Okay, here's me. So we see that there is a direct call to dlopen here. So there's a direct call to dlopen and a direct call to dlsim and a direct call to string to dir, but there's not a direct call to cosine. Instead, we take our frame pointer and get some local variable out and jump to that address instead.